When you read the question, you first need to establish what you are given and what you need to prove, so that you can decide which method of proof is more suitable. In this case, there are two integer variables in the statement that you need to prove, and because that is the only information given, proof by contradiction is the best way forward. The first step is to assume that the statement is false, which means you assume that m squared minus 4n minus 7 equals 0. You now rearrange to isolate one of the variables on the left-hand side. Implies m squared equals 4n plus 7. You can now rearrange the right-hand side to show that it is equivalent to an odd integer as follows, recalling that any integer of the form 2k plus 1, where k is an integer, is an odd number. Implies m squared equals 4n plus 6 plus 1 equals 2 multiplied by 2n plus 3 plus 1. Note that since n is an integer, the term in brackets is also an integer, which means that m squared is an odd integer. Now, if m is an even integer, it can be written as m equals 2q, where q is an integer, giving m squared equals 4p, which is an even integer. This means that m is an odd integer, since an even integer squared is even. So you can substitute m equals 2p plus 1, where p is an integer, in the given statement to obtain 2p plus 1 squared minus 4n minus 7 equals 0. Expanding the brackets gives 4p squared plus 4p plus 1 minus 4n minus 7 equals 0. And upon collecting like terms, it reduces to 2p squared plus 2p minus 2n minus 3 equals 0, which can be written as 2 multiplied by p squared plus p minus n equals 3. Since p and n are integers, this cannot be true, as the left-hand side is an even integer and 3 is not even. Hence, m squared minus 4n minus 7 is not equal to 0, given that m and n are integers.